Okay, in this video we're going to look at some redox reactions of the halogens, in particular displacement reactions with the halogens with the halide ions, and we are going to look at some results and the evidence for the trending oxidizing powers of the halogens. So just a reminder that an oxidizing agent is an electron acceptor. So we're going to essentially look at how well the halogens, and these are the halogens on the left hand side, how well the halogens can accept electrons from the halide ions. So let's just remind ourselves of the colour of the halogens when they're dissolved in aqueous solution, which is water. So chlorine is pale green. Chlorine water is pale green. Bromine water is orange, and iodine water or iodine solution is brown. And up at the top, we've got solutions containing the halide ions, so the chloride ion, so potassium chloride solution would be colourless, as would potassium bromide, or a solution containing bromide ions would also be colourless, as would a solution containing iodide ions, in this case potassium iodide, would be colourless. So we've got a box grayed out for chlorine versus chloride because the chlorine isn't going to displace itself, but can chlorine displace bromide from its solution? And the answer is yes, because what happens in this one is that the observation is that the pale green solution turns orange. And it's turning orange because the bromide has turned into bromine. The bromide has been oxidized and bromine has been formed. Can chlorine displace iodide from its solution? Yes, it can. And when this happens, the solution turns brown. And that is because iodine is formed. So chlorine, the most reactive of the three halogens that we're having a look at, can accept electrons or can oxidize bromide, and it can oxidize iodide, causing them to turn into the halogen in the solution. Bromine versus chloride is coming next. So we start off with an orange solution, and the solution remains orange. And that's because the bromine isn't able to accept electrons from the chloride. So we've still got bromine here. We don't form any chlorine. And then we're not doing bromine versus bromide. If we move on to look at bromine versus iodide, what happens there is that the solution would turn brown. And that is because we're going to get iodine being formed, so the iodide ions are oxidized to iodine. So the bromine is able to accept electrons from the iodide. And then if we look at the last row, we've got iodine versus chlorine. Well, there's going to be no reaction there, so the solution is going to remain brown. And that's because we've still got iodine present. No chlorine is coming out of that solution. And then iodine versus bromine, the solution remains brown. And that's because we've still got iodine present, and the bromide ions stay as bromide ions in the solution. Sometimes it's a little bit tricky to see if the orange colour or the brown colour, orange colour of bromine water or the brown colour of iodine is in the solution. So what you can do, if you're unsure, you can add some cyclohexane to the test tube at the end of each of the tests, and put a stopper in the top and give it a shake, and that will help identify which halogen is present, and that's because the halogen dissolves into cyclohexane more readily, and the colour of the top layer, because cyclohexane is less dense than the water, will help you identify which halogen is which. So you can really see if it's bromine, because if the top layer is orange, that means that it is bromine present. And if you're unsure whether the brown colour was orange or brown, if you dissolve it in cyclohexane, you get a pink-purple colour, which is from the iodine being dissolved in the cyclohexane.